Good afternoon everyone. Today's my topic is basic page replacement and before page replacement, which comes under paging. So before going to basic page replacement, we will be seeing what is paging. Just an overview. So this is how is the representation of paging. So recently all of you have bought your laptops. In that you will be seeing STD. What is STD and STD? Do you know? You have bought laptops for engineering sake, but that's other topic. We will not use laptop for the sake of engineering. What you'll do? You'll see movies, download movies, web series and all, and that all will be stored in this HDD. HDD and RAM are storage spaces. HDD is permanent storage space, RAM is temporary storage space. In HDD what will happen is, suppose this is a RAM and this is HDD. In paging, a copy of this RAM will be present. This is a virtual memory space. It is a virtual memory space. From your virtual memory space, all the files will be transferred. Here a page table will be maintained, and from your page table we will receive and give the information. So what does paging do? As we know, it is increasing our RAM size. So RAM is generally it is very costly. So by and HDD is not so costly. It is less costlier than RAM. So it is like a jugaad. Paging is nothing but it is like a jugaad which will take one more RAM and which will cut down our cost. And it improves our memory utilization. How does it improve our memory utilization? Consider 10 frames. By 10 frames I mean 10 empty blocks. In that 10 empty blocks, consider two processes, P1 and P2. P1 will be allocated 5 blocks and P2 will be allocated 5 blocks, so that we can do two processes simultaneously. So that's how our memory utilization will be improved. So now we'll start with our concept, basic page replacement. So why does the need of page replacement comes? Why do we do the page replacement? We have understood so long what is why does page fault? Why does page replacement occur? Can anybody say?
Because there is a page fault.
When there is a page fault, we have to do page replacement. And when there is a page fault occurs when the desired page is not there in our list. So to do page replacement, we need a free space, right? So that free space is called as frame. So if a free space, that is frame, is free, we can directly do the page replacement. But if the frame is not free, what we'll do? We'll check which frame is not being executed or which is not running the process. We'll take that frame and we will empty its contents by writing its contents to the disk. And after that we can do page replacement once the frame is free. So here is the stepwise representation. First we have to find the location of the desired page. In the disk we will find the location of desired page where it is present. After we get it, we will find a free frame. And after a free frame, we will use the free frame if it is free. But if there is no free frame, we will use the page replacement algorithm, which I will be teaching on before. Then we will select a victim frame. Victim frame is the frame where we will do the page replacement. Then we will write the victim frame from the disk. That's all the page replacement. So here you can see this is the victim frame. It will go to the disk, and the page we want from the disk will come here. And this is the page table. When this will go to the disk, here it will become invalid. So that next time we will go to fetch that page, we will come to know that it is invalid. So and the next page which comes, it will become valid. So that we know that it is present in our memory. See, if there is free frame present, we can directly do the page replacement. If there is no free frame, we have to do two steps: page out and page in, as I had shown in the figure. Next, we can reduce the overhead by using a modify bit. So, what is a modify bit? When we do consider a page, if you modify it, then it is called as modify bit. It is there in the name only. In modify bit, suppose if you if you have the data A, if we add the data B to it, then we will add modify bit to it. This will be done by the CPU. So when we are doing the page replacement, we will check if that frame has modify bit or not. Why we are checking this? Because if the bit is set, we know that the page has been modified. So in disk there is a before frame. It was before modifying. In disk it is present before it is modified. But now here it is after the modification the page has been changed. So if the bit is not set, if the bit is not set means it has not been modified. What we will do, we will not do the page out. We just do the page in. We just delete it because in this already it is present. So it will cut our process by half. See, this page out we were doing right. We will not do this page out. We will just take the page in. So this process is reduced. That is the use of modify bit. Our process will become faster. So page replacement is basically demand paging. So what is demand paging now? Demand paging is nothing but we will not take the entire process. We will just take a frame by frame process. Suppose suppose if there are if suppose the process contains many processes. Consider 100 process. What demand paging? What happens is we consider first 10, then afterwards next 10. So as until 100 we will do that. So to do that demand paging, there are two main problems. One is we must develop a frame allocation, and this is a page replacement algorithm. So uh, there is one thing called as reference string. So what is this reference string? It is the number of pages. Suppose 2, 3, 4, for example. These are the pages, and it will make that reference for the CPU. It is like reference. So after 2 it wants 3, after 3 third page it wants 4th page. So these are the consider this as the pages, and 0 1 1 0 0 0 4 3 2, and here your number of frames means empty blocks. The x-axis is number of frames and y-axis is number of page faults. So if we see the graph, what can we analyze from it? Can anyone say? As the number of frames increases, the page fault is decreasing. In this case, it is like that. So now we'll go to our algorithm. So this is the reference string generated. defecting in this reference string. 7 next 0 0
1,
1
2,
0
0,
0
3, 0, 4, 2, 3, 3, 0, 3, 2, 1. 2, 0, 1.
So we solve only this much now. So we will consider 3 frames, means 3 empty spaces. So here first page it wants is 7. So we will consider this as frame 1, frame 2, frame 3. So first page is 7. We will take 7 here. So next page is 0. 7, 0, 1. Till now there is no problem. There were 3 frames. We put that pages into this 3 frames. Now 2. 7, 0, 1. So where do we put that 2 here? So after 1. But what's the name? First in, first out. So first is 7. So we have to put that first out. So what it will become?
2, 0, 1.
01.
So it will become
2, 0, 1.
2, 0, 1. So this all are page faults. Next is 0. 0 is already present. So it's a page hit. So we will not write the page hit once. So it will indicate our page hit. So next is
2, 3, 1.
So what we will replace here?
2, 3, 1.
Yes, we will replace 0 because after 7, 0 was present. So according to first in first out, we will replace 0 and we will place 3. So what's the next? 0. 2, 3 and 0. So 3, 4.
4, 3, 0.
कुछ स्ट्रेस ना हो तो आराम से कर ले चलता है हाँ वो तो हमारे
Next we have to replace 3.
4, 2, 0.
Next we replace 0.
4, 2, 3. 0, 2, 3.
Is already present, so we will not. 2 is also present.
8.
So next is 3, 2,
1.
1, 2, 0. Tell me the reference string.
1, 2, 0, 1, 7. 0, 0, 1, 1, 1, 7, 7.
7, 0, 1.
पहला होगा ना उनको देखिए आफ्टर में दाखला सकते
ಏನು ಹೇಳ್ತೀನಿ ನೋಡ
ऑफिस चलते नहीं इवंग इंग्लिश बरंगिಲ್ಲ इवंग शिकते जॉब सेम डान्सर गते गाना था डान्सर अंತಾನೆ इवंग
So what will come next?
0,
1.
स्टँड अप कॉमेडी घेतलं
Again it's a hit. So
फॅट्स
Wait. First we replace 3. We replaced that 0. So next we have to replace 1. So what will become 0, 7, 2. And this is a page sheet. Then 0, 7, 1. So here, how many page sheets are there and how many page faults are there? Can you tell?
1, 2, 3.
Page faults are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 page faults and 6 6. So this is how you can calculate page faults and 6 6. So as we saw the graph, as the number of frame increases, the page fault decreases. So I will give it, please open your notebooks.
ಸಾಲ್ವ್ ಮಾಡಬೇಕು.
ಇವಾಗ ಪ್ಯಾಂಟ್ಸ್
So we will now try to understand what is Farade's anomaly. So this is your reference link. Please note it down.
ಫೋಟೋ ಡಿನ ಫೋಟೋ ಜಿಯೋ ಟೈಪ್ ಫೋಟೋ
Consider 3 frames and solve it.
ಜಿ ಪ್ರೈಮ್ ಇತ್ತು.
Tell me how many page faults arise when we consider 3 page faults, 3 frames.
Using 3 frames. Nine. Correct answer is 9. So 9 page faults occurs. So now do considering 4 frames. This will be the last one. Take 4 frames and solve it. What you have to do is consider 4 boxes. 1, 2, 3, 1, 2, 3, 4. Consider 4 boxes and solve it. And tell me what is the page fault. How many page faults? 2 is. And page faults? The answer is 10. So here we get page faults 10. So here you can see that when we consider 3 frames, the page fault is less. And when we consider more frames, the page fault has become higher. So it is different than we saw the graph. first we saw that as the number of frames increases, page faults decreases. But here it is different. So this is what Valaday's anomaly. So in this graph you can see that at 3 number of frames, the page fault is 9. At 4 number of frames, the page fault is 10. So I conclude my sentence.